Okay, so let's take a look at homework number 2, Ohanian 4.18. This problem, let's see if the camera will focus. 4.18 gives you a particle with an initial position of r equals 0, an initial velocity, v naught, equals 3i plus 2j, and a constant acceleration, and asks you when does it reach a maximum y coordinate, and what's the position vector of the particle at that time. Okay, so let's see. We are given r naught equals 0, v naught equals 3i hat plus 2j hat. I'll stick with the book's I, j, k if they had it instead of my preferred x hat, y hat, z hat. And that's a vector. And you're given the acceleration, which is I hat minus 4j hat. Now notice the acceleration is a constant. There's no time in here. Okay, so that we can use the constant acceleration formula. We won't have to worry about doing integrals. We're asked for the maximum y, and you should know now to translate maxima occur when the velocity in the y direction is 0. Of course, minimum occur too at vy equals 0, so we'll have to distinguish between those, but if we solve for all the places where vy equals 0, then we know we have all the maximum and minimum. Let's go ahead and work this out now. So our general formula for velocity at any position or any time will be v naught plus at. These are both vectors too. Okay, and that just comes from the constant acceleration formula for how velocity is connected to acceleration in time. V equals v plus at in one dimension and just vectors in 3 dimensions. So I can write this out in terms of its components. In the I direction, okay, v naught has a component of 3. Now this will be meters per second, but I won't write units here. You might want to. That can sometimes prevent making mistakes, but I'm being a little lazy. Plus a times t, and in the x direction, a is just 1 times I hat, so we just have plus t. You can't add a 3 in the t unless you have the dimensions right, so this is 3 meters per second, okay, and there will have to be a meters per second squared for the 1 here, so when you multiply by t, you have the right units. In the j direction, we have similarly, in the j direction, v naught is 2, plus at gives us a minus 14. So now we have an expression for the velocity as a function of time in terms of the 2 vector components. Okay, we're asked for when vy, or we know we want when vy equals 0. Vy is just the 2 minus 4t term, the j hat term, and we want to know when that's equal to 0, but you can solve this pretty easily with algebra. Just put 4t on the other side and just say t equals 2 divided by 4, t equals 0.5 seconds. So that's when the velocity in the y direction is 0. And so that's a maximum component of y. Now you should double check that to make sure it's not a minimum, but we know at earlier times when t equals 0, okay, then vy is positive, which means the thing is moving up. When t is bigger than a half second, say 1 second, then t equals 2 minus 4 is negative 2, so velocity is down. And that tells us that whatever it is here has to have been a maximum. So that's our maximum y occurs at that time. Okay, so now we have to find the position. What is the position vector at that time? Okay, so r, the position vector, equals r naught plus v naught t plus 1/2 a t squared. Now remember, this came from x equals x naught plus v naught xt plus 1/2 a xt squared. But now we're working in two-dimensional space, not 3, but we have to make this a vector expression. But it's still basically the same as we had in 1 dimension. Okay, so I can just write this out, but first I'll note that we're told r naught equals 0, so I'll just ignore that. And so now I have to write out in each component, I and j, how we add v naught plus 1/2 a in order to get r in that direction. So this is equal to, in the I hat direction, okay, V naught times t, well, V naught is 3 times t from that, plus 1/2 at squared, and the I hat direction, a is 1, so that's just 1/2. I'll put it in there, but you don't have to. 1/2 times 1 times t squared. And that's the I hat component. Okay. Now I have to add the j hat component. Let me just do it down the next line. J hat component. So I look at the j component of V naught. That's 2. So I have 2t plus 1/2 a, which is 4 or minus 4 in the j hat direction, times t squared. So this is my expression for r in terms of its components. Let me just simplify all these terms and just say that r is equal to 0.5 t squared, that's this term, plus 3t I hat plus negative 2t squared from minus 4 times 2 minus 2t squared, oops, not yet, plus 2t from the at term, or I'm sorry, from the 2t term there. So there I have a bracket times j hat. The question was, what's r at t equals 1/2 a second? All I have to do for this is plug a half in everywhere I have a t. So that just tells me that r is equal to 0.5 times 1/4, that's t squared if you plug in the half, plus 3 times a half, that's the I hat direction, plus minus 2 t squared if t is a half is 1/4, plus 2 times t is a half, 1/2, j hat, okay, and then just do the math. 3 times 1/2 is 1/2, 1/4 times 0.5 is 0.25, so r equals 1.625 I hat plus, and add these together, a half, okay, plus 1, I'm sorry, minus a half plus 1 will give you plus a half. And that's j hat, and this is all in meters since I haven't been carrying units around, which would let you check your work if you did that. And I used to do that when I was a first-year student, but now I'm not because I'm confident I've got those right. So that's my solution. Problem 4.18 done.